Hi everyone. Welcome to AI-based malware detection system for Windows PE files. In this video, we'll show you how we built, trained, and evaluated our machine learning model using Google Colab. Let's get started. We upload our dataset containing various features extracted from PE files. The label column indicates whether the file is malicious or non-malicious. Dataset.head of it will display the first 5 rows of the dataset. Dataset.tail will display the last 5 rows of the dataset. Before training a machine learning model to detect malware, the very first step is to clean and prepare the data. This is called data pre-processing. Feature selection, a critical step to improve model performance by keeping only the most relevant features. We use the extra trees classifier, a powerful ensemble learning method, to calculate how important each feature is to predicting malware. This classifier ranks features based on how much they help the model make decisions. The most influential feature is DLL characteristics, followed by machine and characteristics. These attributes play a key role in distinguishing malicious files. Entropy-based features like sections max entropy, resources max entropy, and sections min entropy are also selected. These reflect the randomness in different sections of the file, which often differs between malware and legitimate files. Now that we've selected the most important features, it's time to train our machine learning models to classify files as either malware or legitimate. Here we used decision tree and random forest algorithms to train the model. Based on accuracy, we selected random forest for classification with 13 features. After saved into pickle files for deployment. Once the website is deployed, the first step for a user is to sign up. This helps us create a unique account for each person. After signing up, users can log in securely. The system ensures that each user sees only their own scan history. So, whenever a file is scanned, the result is saved in that user's scan history. This way, every user gets a private and personalized experience. At the top, you can see an overview of our dataset and model training. We trained on over 138,000 PE files, with 70% used for training and 30% for testing. Our final model achieved an impressive accuracy of 99.41%. Click on Test File, it will redirect to Scan page. First, the user selects a PE file, such as .exe or .dll, by clicking the Choose Files button. First, I upload a clean, legitimate file, say, a trusted.exe or .dll. After clicking Predict, our backend model quickly analyzes the file's internal structure and behavior patterns. Based on its trained knowledge from over 138,000 PE files, it confidently classifies this file as legitimate. The result is instantly shown on the screen, and this prediction is also stored under the user's scan history, so they can revisit it later if needed. Now, let's test with a second file. This one is known to be a piece of malware. After uploading and clicking Predict, the model examines all the important features, like unusual section entropies, suspicious subsystem values, or abnormal header info. Within seconds, it flags the file as malicious, highlighting the power of our AI model, especially the random forest classifier, which gives us over 99.41% accuracy. When a user clicks the View Past Reports button, they're taken to a page that shows a complete list of all the files they've previously scanned, along with their prediction results, legitimate or malicious, the file names, and scan dates. This scan history is user-specific, meaning each user sees only their own past reports after logging in. If a user wants to remove any record from their history, for privacy, or just to keep things clean, they can simply click the delete icon next to the entry. In the About section, users can find detailed information about the project. When you click on the Logout button, you will be successfully logged out and redirected to the login page. On the home page, there's a button labeled Download Desktop Version. When a user clicks this button, they can download our desktop application, which works offline, so users can scan .exe and .dll files without needing an internet connection. Once you've downloaded and opened the desktop application, you'll see a clean interface with buttons like Upload Files. Click on the Upload Files button. This allows you to select and upload multiple .exe files at once. As soon as the files are uploaded, the app runs them through the trained random forest model and begins the prediction process. In just a few seconds, it will display the number of files that are malware and the number of files that are legitimate, all right on the screen. This makes bulk scanning fast and easy, even when you're offline. In the desktop application, you can also view your past scan history. Just like the web version, it shows a list of previously scanned files, along with their prediction results, the date and time of the scan, and whether the file was malicious or legitimate.